Yeah, so I have to admit I'm on ops rotation this week at Medium, and so come Monday morning, nothing was happening, and I decided to rewrite these slides to make them more code-focused. And then, of course, by Tuesday, everything had completely blown up. So this is actually the first time that I've been running through this iteration of this talk, and I will do my best to keep it under 30 minutes so we can all get to lunch and we can address questions, though I'm happy to stay after if people have questions. So I titled my talk, Enabling Big Data and ML for the Masses. Here's kind of what I had in mind to talk to you guys about. Talk a little bit about what we do at Medium, give a little bit of a technical overview of our big data setup, although I wanted to focus more acutely on the Scala that we had written. Talk about what we had on our old platform, what we rewrote on the new platform, and some of our ideas for extending and testing under the new platform. I included a use case about how we created ML jobs on this platform. I'm not sure if I'm going to have time for that, but I'm happy to answer questions or, if I talk quickly. Okay, so what do we do at Medium? Oh, by the way, I really like cats too, so you might see some cats in this presentation. So there's a bunch of people out in the world that like to consume written content, and there are writers that like to write content. And so Medium is the platform, and it's the platform that's connecting these two groups of people together. And of course, I think it was early last year that we launched a program by which we pay writers for their content if they so choose. So where does big data and ML fit into this sort of business case? On the one hand, we have recommendation teams that are trying to match readers to the content that they want to read. We want to automatically annotate content coming onto the platform from the writers. We've sort of been launching a curation process, but we definitely are at a scale that we can't do that all manually. And we have some ETL pipelines that support product-facing features, such as paying out our writers. And of course, we have a product science team that's trying to measure everything. And so we're building out ETL pipelines for them too. And so what we found was we had a very, very small data engineering team. And in fact, for a while, we had no data engineering team. And we were trying to push people more and more into a data-focused business decisions and measurement, and it became just too much for the data engineering team to be writing all the pipelines. So this is kind of the solution that we had to come up with to sort of spread the love around to the rest of the company and enable individual teams to write their own pipelines. So this is kind of an overview of our entire setup. An engineer will write some Spark code and submit it to our CI server. We have a cron running that's checking the state of the jobs and submitting requests to our Spark cluster. And then our cluster reads from the artifact that the CI server publishes to S3 in this case, and runs the actual ETL job against the data in our data stores. So when I previously gave the talk, I talked a little bit more about this 10,000-foot view. And I put a link to that video if you guys like to hear my voice. I think it's pretty terrible on video. But for this particular talk, I want to focus right here on the kind of the things we did in the Spark side of the world. All right. So what were we doing before this rewrite? So this is kind of an example. We're trying to match cats and owners. Maybe we have cats out on the street. So this pipeline that we've written, we're treating each job as a separate application. There's of course a main function that the whole infrastructure is calling. and we're treating each individual job as an individual application. We're using mix-ins to provide functionality for these jobs through inheritance. And the team wrote some utilities that support the various extraction and data loading tasks that need to happen. So how would we configure these things? We used the medium job trait was kind of the central trait that we would use. And it was a mix-in, so it would provide kind of this functionality. So we were using just command line flags that were being parsed by this little Twitter util library. And then we would pair the job, the Scala job, with a YAML file. And so you can see here's an example of some job level configuration that we'd set up. We're big believers in protobufs at Medium to describe all of our schema. So in this case, we were, I kind of messed up this example, but like, for example, if you wanted to inject the protobuf class into your job, this is how you would go about doing it. And then we had various other sort of what we considered platform level configuration values. So for example, what's the Redshift schema that I'm loading my data to? Should I truncate columns when I load? And then what the S3 bucket means is we're actually writing temporary results to S3 to do post-processing during the loading step. And then there's this sort of second level of configuration that we were in the middle of doing, and that was all injected through environmental variables. So in this case, we would allow pipelines to see the pipeline name that we were running, and the import ID was kind of how we segmented the data. So it would be, year, month, day, hour, and we were constantly running bulk jobs to extract and load data over these what we called import IDs. And then those were available as a mix-in variable through the medium job trait. So they were actually available through the platform elements, in this case the Redshift loader, and to the individual pipelines. All right, so that was kind of the setup that we had going into this, but we realized that there were a couple of problems as our data team got fewer and fewer, and we were having to push more and more of this work out to individual product teams. For one, there was actually very, very little testing done, or automated testing, I should say, done with these pipelines. Because of the mix-in structure, we basically required you to have a database connection to run any sort of tests, which means when people were writing, they're having to do a lot of manual testing, a lot of manual verification, which was very cumbersome and slow. Because our product engineers weren't familiar with Spark or Scala in some cases, they were constantly reinventing the wheel. They were looking at what code already existed. They were copying and pasting huge swaths of code. They didn't really have a sense of how to tune things or what things meant. They just wanted to get it to work. So they'd get it to work, they'd push it up, they'd do some manual testing, and then that was good enough. So it meant our code started to get like really, really ugly and unmaintainable. Yeah, like I said, we were copying and pasting paradigms all over the place. And like the platform team kind of realized it had sort of lost control of our data platform. In terms of configuration, there's just a bunch of stuff that we could infer based on the environment that we were pushing data to. So we have three main environments at Medium: a dev environment, staging, and production. And so we're making these product engineers go through a lot of these configuration steps and provide all this configuration data that they really didn't need to, because we realized we could just infer it from the extraction and loading environments. And in some cases, like in this S3 bucket case, it wasn't really clear what we were configuring. Are we configuring this Redshift loader mix-in? Are we configuring this Redshift connection mix-in? It was just very, very confusing how everything fit together. And then in terms of the environment variables, specifically with the import ID, there's no type safety. So there's like this is all string based, so we're like kind of awkwardly using these things as strings all over the place, which didn't work, and we were having to wrap it a lot to get information out of the import IDs. And of course, when you use environment variables, that makes testing very, very cumbersome as well. So those are kind of the problems that we were encountering. And so we sort of set out to rethink how the data platform could look such that product engineers at Medium could write their own pipelines and have them reasonably tested, and sort of maintain control over the important pieces of data extraction and data loading at Medium. So what we did is we reimagined sort of the structure of the ETL job. And of course, just the acronym itself, ETL, provides the natural roadmap to do that, right? There's data extraction, data transformation, and data loading. So what we decided is that the data platform would concentrate on data extraction, data loading as platform-specific pieces. And all we wanted the product engineers at Medium to do was concentrate on the data transformation, which would support whatever product initiative that they had. So this is kind of how we laid it out to them. We will provide all the services for extraction and loading. You guys just concentrate on the transformation. These will be services that you can consume. All right, so, and this is sort of our vision of the new world. This is our cat owner matching job rewritten. So we had to maintain this application model because we didn't want to rewrite all in that 10,000 foot view slide, we didn't want to have to rewrite everything around that. So we kind of had to maintain this one application, one job paradigm. So we did that by splitting out the actual job from what we called the job runner. So the job runner carried the actual main main method that the normal platform could execute. But we split out the data transformation piece into its own class, which means we can instantiate on its own, we can test it on its own, and we can run dependency injection. So we decided that we're going to sort of throw away this idea of inheriting all the utilities that you needed for extraction and loading, and we're going to move into a composition through injected services. We decided that we were going to redo how we configured these jobs. So instead of there being sort of this this unclear link between how you're configuring things and what the job needed and where all the configuration lived, we wanted to make it very, very clear. For example, this cat ownership matching job was reading data from S3 and pushing data into Redshift. So we wanted to make that very, very clear, and so that the product engineers at Medium could understand kind of what was going on and what they were programming against. And a nice thing about that was we kind of got this type safety, which I will show you in a little bit. But you can kind of see, because we're using polymorphism here, we can push the instance of the cat ownership matching job directly into our extract S3 and directly into our data loader as the main configuration object, which was kind of cool. And then, of course, we worked hard on developing really clear, easy to understand contracts for our product engineers. So that when you looked at data extractor.extract S3, they knew exactly what was going to happen. When they looked at data loader.load RDD, they knew exactly what was going to happen. And it became much more obvious how to use these tools. So here's kind of a look behind the scenes at our runner trait. We set up this implicit Spark session that can be used throughout the platform. Some people don't like this feature of Scala, but I actually kind of like it. And you'll see in several of the example code that we use this all over the place. And it just means that we don't have to pass this Spark session around, which I think was very useful. We used a library called App Builder, which is a microservices library built for Java and Scala. It's open source, written by yours truly, so there's a little bit of bias there. But what it allows us to do is set up package scans for new services to add to the dependency graph. And I'll show you in a couple of slides why that was important. And finally, we added the actual job class that we configure in the job runner. We add that to the dependency graph, so all our nice platform services get injected into the pipeline job class, and they can be used by our engineers. So like I kind of mentioned before, we also reimagined how we configure these jobs through polymorphism. So the source configuration would be attached to the data pipeline, and we just make that itself a data source that can be passed directly into the data loader. Or sorry, I messed up these slides. That's supposed to say the data extractor. I got these backwards. And then of course the destination configuration gets added to the pipeline, which itself is a data destination object, and that's pumped through the data loader in this case. What was cool about this is it meant that we could use these pipeline objects as actual connection configuration objects, which meant we could pass them to other services. And there's an example of this. When we started to get into the ML platform stuff, this became extremely useful. And it was kind of neat because we sort of came up with this polymorphism idea independent of wanting to do the ML use case. And when we got to the ML side, it was just all there, and it worked beautifully. So this is how we started configuring jobs in this new world. We started using convention over configuration. So you can see here the CAD ownership matching job uses the S3 data source and the Redshift data destination traits, but there's this source environment and destination environment. So we just ask our engineers, tell us the environment, product, staging, or development that you want to extract data from. Tell us the environment, dev, staging, prod that you want to load data to. And we're going to infer a bunch of configuration on your behalf without you even having to think about it. And then, of course, just some good programming. We introduced these hierarchical names so that it would be very clear how we're linking all the configuration to this code. So again, looking at this example, what did this kind of look like? We still supported the job level configuration values, like I talked about before. However, we just required our product engineers to tell us the environments, like I mentioned. We did a bunch of inference there. And then it became very, very obvious where specific data extraction and data loading configuration map to. So this cut way down on the amount of configuration we had to produce manually for these jobs, and it just helped speed the process up. It helped provide clarity in the whole platform for the product engineers. In terms of environmental variables, because we were using dependency injection, we could actually, the job runner would read the information from the environment variables, and then we would bind that directly into our dependency graph, so that anytime anyone wanted to write a pipeline or a new service, they would have that configuration easily bindable into, or easily injectable into their pipeline or service, whatever the case may be. And what was great is we were able to provide some type safety specifically around this import ID, which meant we could do a bunch of things like extract timestamps. We could build table names based on it that were safe. We started doing a whole bunch of stuff for that. Cool. So that was kind of our vision, and that's sort of the world we moved to. But in terms of extending and testing the new data platform, we did a lot of thinking about that too. So we decided that we wanted to have a plugin style architecture, which would make it very, very easy to add new sources and destinations to this platform. And so this is a pretty complete list of everything that we've built today. So there's even some cool things like if product science dumps things into just a Google Doc, we can write a pipeline against that, specifically a Google spreadsheet. We can write a pipeline against that without having to like port the data to a database. And the other kind of interesting one that people might wonder about is the SQS plugin on the loader side. We wrote that to support our curation process. So we run curation over a priority queue in SQS. And so we built a data loader plugin as part of this platform to do that. And so if you multiply this out, there are actually 35 point-to-point combinations that we could write. Of course, we don't use them all, but you could if you wanted to. So this is looking at the data loader service that we created with the dependency injection. Of course, we defined a trait to represent our data loader, and we bound an implementing class to that. And then we wrote all these plugins and just injected them right into the loader class, or the data loader implementation. And then in terms of the plugins, it was kind of a similar pattern. We defined these plugins, and you can see that the plugins take a destination which is typed. And so that goes back to our cat matching pipeline, where we could pass the actual pipeline job itself into the data loader, and the configuration would be available for our loader to use, our loader plugin in this case. So this is the beginning of our Redshift implementation. We bind it as a singleton within our dependency graph. And you can see that the environmental variable configuration is available to this very, very easily. And you can kind of see, like I don't have it listed out here, but you can kind of see how we started breaking these things out. There's a Redshift connection factory, which itself is a singleton bound into the dependency graph, which makes things very, very easy. And the data extractor service is defined in a very similar way. One of the differences is we kind of broke out the extraction methods, each one, so extract Dynamo, extract MySQL, et cetera, et cetera. Whereas with the data loader, we sort of decided that we wanted to do it all in one go. Like once they produced their data that they wanted to load, they could just list out the various destinations, which was done in the config file. And that was kind of all done by the platform in one go. So in terms of testing, we sort of did another reimagining. Well, we took how we had reimagined this ETL job, which quite frankly wasn't much of a reimagining. And if you can say the extractor and loader are platform pieces, we can sort of divide and conquer this problem. And so we produced what we called the mocking data extractor, which would send mocked data frames into the transformation code. The transformation code would run the load, and then on the load side, we wrote what we called the asserting data loader, which would just assert all the results of the data that we had transformed. And kind of what this means is that the end-to-end tests we were writing were focused very, very much on the data transformation piece of this pipeline, which was cool because that was the piece that the product engineers really, really needed to test. They didn't so much care how the extraction or loading happened. They wanted to focus on the transformation code that they had just written. So yeah, like I said, we're isolating the transformation piece of this puzzle. So here's a look at our sort of a abbreviated look at our mocking extractor. So within the tests, I have an example in a later slide. Within the tests, the test writer would just tell us what data frames do you want to serve up when the job asks for them. And then we would sort of broke up all these mocks by a mock data source. And the framework is actually, the testing framework in this case is actually smart enough to match the data source with the data source being used by the pipeline itself. So for example, if the pipeline requested data from Redshift, but the next mock was attached to Dynamo data, the testing framework would sort of catch that and say, it would throw an error and say, you're not providing the Dynamo data that the platform is expecting. Similar for data loading, we wrote this asserting data loader, which provided the ability for our product engineers to write asserting callbacks, which would simply run asserts on the RDDs that we got as they were being loaded from the pipeline job. And finally, we wrote what we called I don't know why we called it this, we call it the real Spark service injector, which was this was a wrapper around the juice injector. This whole thing is built on juice at the core of it. And what it allowed us to do is create the same dependency graph, except we bound our mock services into the graph. And then there's this little feature in the app builder library that allows you to override the normal injected services with your mock services. And what that means is we set up this injector. We would extract the job from the dependency graph, and then we'd just run the job because we would know the dependency graph held the mocking data extractors and the asserting data loaders in it. So yeah, here's an example of an end-to-end test with our mocked out data frames, our asserts for expected results, and then we would just dig out our job class, which we know we had put into the dependency graph, and run it. And so this is kind of what we found when we put out this new framework. First and foremost, we got much more and better testing around our pipelines. And number two, like I said, we got much tighter control over the platform elements themselves. And I put in an example. In the Spark world, they're very concerned, especially around JDBC, about overloading the JDBC, overloading the database with JDBC connections if you have too many partitions in your data frame. But because we had isolated the data loader and that was being owned by the data platforms team, we were able to solve that problem and ensure that we didn't do that without the product engineers having to worry about any of it. We got more engagement across our teams. I think we had 3 product teams actually actively writing pipelines. And at one point, one of them came up to me and thanked me and said, Spark programming is fun again. Instead of copying and pasting these large swaths of code, they were using this very easy to understand injection framework with these very easy to understand contracts. And in one case, we even got non-programmers into the act. Our product science head, Gustav here, he himself wrote a pipeline, which was pretty cool. So it kind of validated our choices here a little bit. So just sort of a couple of takeaways from this whole experience that I'd like to share with you. Convention over configuration. And by the way, I don't think any of these are specific to this particular project, but it was sort of things that we realized after the fact. Convention over configuration was very important, trying to limit the amount of configuration these engineers were having to do. Certainly composition over inheritance, because of the ability to write tests against the code being written. Dependency injection was sort of the implementation of that composition. By writing the testing framework and shipping it along with the new platform, we were able to enable our product engineers to do the right thing and write tests. And of course, we had written example tests for them to follow through and understand too. And finally, I don't think this is a surprise to anyone in this room, but developers really like patterns and good names. So the better you can name things, and the more patterns that you can show them that are easy to understand, the more successful it was. Anyway, with that, I think I'm pretty close to time. Here's some links that I threw together. Like I said, I gave a similar talk at a Scala meetup at our offices at Medium, and so that's on YouTube. And Alexi actually interviewed me for that talk. So that's also on YouTube. And I threw a couple of links in for GitHub for some of the libraries we were using. A word of caution on this app builder library. It's still kind of in beta. It's just me and one other friend doing it. So it's a little light on documentation. But certainly if people are interested in that, send me an email because I need to convince my wife that I need time to work on these things. So if people are emailing me, I'll be like, yeah, see, look. Anyway, and I will close with a picture of me and my adoring cat.
Thank you, Tim. We've still got a comfortable amount of time before lunch, so there's plenty of time for questions.
Or I'm happy to stay after if people want to come up and ask questions.
Got a question.
Sure.
For the data structures, you have many like Dynamo,
Yep.
Redshift, etc. You transform the data into a canonical representation, and then you have a single implementation that will bring it over to your, I think, data frame.
Yeah, so that's a good question. So what we did is we followed what I believe is called the robustness principle, which is be liberal in the input that you allow, but be strict in the output that you send. So in this case, with our extractor, we had a very loose definition of what you could extract, in this case, a data frame. And for our loaders, we required you to be very strict in what you loaded. So we used, we would require you to write a RDD specifically around a protobuf. So your transformation code would actually take in a bunch of unstructured data. We would allow all the data coming into the pipeline to be unstructured, but then through the transformation process, we would force you to structure that data into a protobuf and create an RDD, which you could then load, which allowed us to sort of maintain some semblance of sanity around like table creation and everything. So that's one of the things that we were thinking about in that.
I've got a question. It's more of a provocation than
Sure.
a question. Your title was Big Data for the Masses.
Right.
And the approach was to make it easier for developers.
Right.
There are a lot of people like Gustav on your slide who aren't developers and can't really code to save their lives.
Sure.
Is there more of this you can see where people are either writing much shorter code snippets that get compiled into a block constructed kind of in your framework, or even looking at sort of what Hive does, give them the ability to write SQL or other kind of data specification and then compile that into chunks here?
Yeah, no, that's an excellent question. This was sort of maybe a half step along this journey, because we were trying to push this out to people who were engineers. They just weren't as familiar with the framework or Scala in this case.
Right.
But I think if we were to keep going, reasonably we would have to pursue some of the things that you're suggesting. Our product science team they're not going to invest in in Scala. And while Gustav did in one particular case, and that's great, that's not a sustainable model. And what they really know is SQL. So so yeah, I think the next step is going to be something like what you suggest, which is give us the SQL and we'll load that into the platform wrapped around all these services, and we'll execute.
And you'll be able to say where the data is coming from and where it's going to.
Exactly.
In this framework
right.
here.
So it would be maybe a almost meta programming language, but it'd be much simpler, right? Much easier for a non-developer to understand.
Yeah, you wouldn't even have to know. I mean, you've removed so much boilerplate and so much cruft, but for these people, it seems like we need to remove.
Yeah, even more. Yeah, I agree. I agree with that.
So did you mention many folks won't know how to write code for scalability concerns? So did you try to address that also here, or was it?
Sorry, can you?
So did it at all address folks who won't know how to write scalable and performant code, how to abstract about that out?
Yeah, so we were doing some of that, like I mentioned with the JDBC connection example. That wouldn't be something that people would really understand. So by abstracting away the loading, and extraction, we were able to sort of process some of that. I don't have a good answer for you in terms of within the actual transformation code itself. It was a little bit of a wild west because we just didn't have the resources to review everyone's code. And so some of that we were trying to make up on the operations side, we would spin up just larger clusters if we needed to do that to run people's code. And we'd sort of monitor the cluster size and how much money we were spending and try to deep dive into particular areas from an operations side rather than from a pure coding side. Yeah. Yep.
How did your people who were writing these transformation pipelines, what sorts of tests were they writing? What sorts of framework were they using?
Yeah, so they were writing tests similar to this one I had on the slide. They were writing, and actually there were two sort of varieties of tests. They would write unit tests on.
He's more stirring.
Yeah, maybe.
Yeah.